Hello, this is Riku Rempelä from the Trainees Help Desk. This time talking about force in water. Force is an invisible thing, and usually we talk about things we see, and therefore force is a bit hard concept for people to understand. And therefore good to go through some of the background and a bit link the force into something we see. Usually when I start working with new people with the force measurements, I start by asking them that what makes the swimmer move to the other end of the pool. It's a good way to calibrate the level of discussion and a bit understand that what they think about it. Let's go through how it happens. So when the swimmer puts the hand in the water, they push against the water and the body moves forward. And the key concept on making that understandable is this hold on the water. So when they hold the water, it always slips a bit, the hand slips a bit in the water, but the better they are able to hold the water, the more efficient they are on moving to the other end of the pool. And this hold on the water it's a conceptual thing, something you can discuss about, but force is a simple way of putting force in the context is that it's a way to make the hold on the water visible. So this is what it looks from the hand perspective. That hand goes in the water, it slips a bit, and then it launches forward to the next stroke, and that's the way they move to the other end of the pool. And looking this and on this one, then there's some slippage and then there's some progress. And the way to make that visible through the force measurements, and when we make it visible through the force measurement, this is what the force production during a lap roughly looks like. So we are not built in the way that we would be able to apply similar amount of the force throughout the stroke cycle. In the beginning and in the end, there are smaller muscles available, and in the middle, there are bigger muscles available. And also other perspective is that in the middle of the stroke, there's a bigger area against the water and the bigger muscles available. So it makes sense to maximize that part of the stroke. Meaning the peaks in the force are always in the middle of the stroke, and the low valleys are then in the end and in the start of the stroke. And if we on the same curve draw the velocity of the body, this is what it roughly looks like, that there's a clear connection. So when you have the bigger area against the water, bigger muscles into use, then you go fast. And according to the measurements, the lag between those two is 0.1 seconds, depending a bit on person and the details, but on the average it's 0.1 seconds, meaning that immediately when you start dropping on force, you'll start slowing down, and it's really like that, so really fast connection. And that's the key thing with the force measurements, that you are able to make visible the hold on the water on 0.1 second accuracy. And also when we are talking about force, that's the way to make the muscle action visible, and then you are able to link those details into the muscles and how they act. It might sound like a tiny detail, this 0.1 second detail, but if you think that there are 20 strokes done on 50 meters swim, and then that 0.1 second difference on each of the cycles already accumulates to 2 seconds per 50 meter, which starts to be a relevant thing for the end results also. This is the high-level summary and the force. More details on the next episodes.